This project is the rod storage device sponsored by TNT Tools. Team 20 made this, composing of Caleb Capps, Trevor Vetters, Zach Peters, Asher Behrens, and Darwin Bowman. The audience of this project would be the line workers at TNT Tools. The goal of this project is to design and manufacture a device capable of presenting steel rods upright to an operator for ease of access. Now, a quick functional overview for our project. As you can see, we have two bins on top of a frame. Inside of this frame, there is a motor and gearbox, which is the rotation mechanism for this project that we have here. I will get more into depth in the next slide on how it works, but this is what it looks like. The intent of this project is essentially to help the line workers reach into the bins with ease. As you can see, we included a flow diagram here to show the process. So to start, the bin is empty, then a button is pressed. The box begins to rotate towards the horizontal position. Once the box stops rotating, the empty bin is removed. A forklift then loads the full bin. The button is pressed again. The box begins to rotate to the vertical position, and then the box stops rotating. That's where this process would end. And being in the vertical position, it's much easier for the line workers to reach into the box that way instead of reaching down to the horizontal position, because these rods can weigh a lot and there are also a lot of them. Now for some of our major specifications. For the first one, the total project cost, we aimed for $8,000, but our maximum limit was $10,000. This would cover everything, including materials, services, shipping, and anything else that may pop up. We shot for $8,000 because we're supposed to have a 20% tolerance. The device's weight must not exceed 2,500 pounds. We did this so the forklift could lift it up if we needed to, and it's also a public safety issue. The cycle time for operation, including offloading and reloading, should not exceed 7 minutes. We are going to beat this by a lot, but we were set the 7-minute bar because that is what TNT Tools currently has to cycle everything out. Electrical disconnects such as lockout, tagout, and breakers will ensure compliance with the standards that were given. The device should not tip until it reaches a 28-degree angle once struck from the side. This specification is intended to ensure that if struck by a high-low, the device will not tip over, because with this much weight, that would be a huge public safety risk. The device must have a minimum lifespan of 260 cycles. This seems very low. However, with the load that it's carrying, as well as being used once about every 3 weeks, that is about 10 years right there. And that is also a low ball. Electronics will be splash protected according to standards. This is to make sure if there's a leak or worst case a flood, our device will be protected. An e-stop will halt the machine in case of emergencies. This is to stop the machine if there is something wrong that is unexpected, not detected by the motors. There's a manual shut off button here. The biggest obstacle overcame was the rotation mechanism selection. We had a lot of different ideas at the start. We had a hydraulic cylinder, we had a pneumatic cylinder, we had a linear actuator, we had manually lifting up with a forklift. However, after a lot of thought, cost comparison, and safety precautions, we landed upon the motor and gearbox, cable and winch essentially. So this is the heart and soul of our project. This is what makes it more than just a glorified rod rack. The motor and gearbox. So I thought this was very clever in this project. Instead of using two motors, we used one motor with two pulleys and two cables. So essentially, when you put the motor in forwards, it pulls from one end and almost pushes at the other to allow this platform to go into the horizontal position. It stops once it receives the signal from the VFD to stop, once it hits the inductive proximity sensor. Once another start button is pressed, it will go back down to the horizontal position, which is the default position for loading and unloading. The motor does say that after, I believe it is 60 seconds of use, it must rest for 15 minutes. That's because it's about 2 horsepower and can get very hot very quickly. Some of the key features we implemented were the rotation mechanism, which was the cable and winch system. That was probably our most impressive feat and what we put the most time into, as it was the biggest obstacle overcame selecting this. The emergency stop button, that was also a very important part of this project. Motor protection, that was very big. Finding a way for the frame to be held and also protecting the motor, because if this motor does not work, then this gearbox will not turn and this project would be useless. It would just be a glorified rack for rods. So we put a lot of thought into that. Lastly, we have our stack light. This was implemented as a safety feature to tell the operator and anyone else who may be in the area if this is in use or not. It may be obvious to some people it's in use, but when you're in an environment that's very loud and has a lot of things going on, it may be a little bit tricky. So we have a stack light that shows green as it's going, yellow as it's coming to a halt, and red it is not moving. Some important technology used. The 1766 Micrologics PLC was our control unit. 460 volt WEG variable frequency drive, also referred to as a VFD, was also very important. The 460 volt Iron Horse AC motor was essentially what ran this project, and the inductive proximity switches. They were all used together in a very simple way. So you have this PLC, and once you press the start button, it reads the proximity switches. If the boxes are at one proximity switch, it sends it to the other one. So this PLC would send a signal into one of the VFDs, and each VFD has two different signals going into it, one for forwards and one for reverse. Once you pulse the forwards high on one of them, then the VFD will start the motor, which will then turn it until it hits the other inductive proximity switch. This is what we used for our safety mechanism as well as our rotation mechanism. And finally, for our narrated video, the position seen below is the horizontal position. As you can see, this is meant to carry a lot of weight as the frame is extremely reinforced. In this position, you can take off the empty bins with the forklift and load on full bins. As you can see, the bins have forklift pockets. Once loaded on, you may then turn it vertical, as seen here, and the operator may now simply pick the rod out of this bin. This cycle time will not be as fast as shown here, but our estimate is about 1 minute. In summary, this product will increase the public safety and health of the operators at TNT Tools. Thanks.